Currently we are located somewhere in the middle of nowhere. Some place where it's really hard to get in. And that's a place where you could potentially want to install your IoT device. So how to debug your IoT device placed in the middle of nowhere without exiting your home and coming long kilometers here? Well, in the tutorial, I want to show you it. In the first part of our tutorial, we'll create two simple scripts which gets data from our I2C based sensor and writes them into a database inside of our Raspberry Pi. Also in that video I will show you how to easily manage the script remotely using Dataplicity, but in the next video I will show you how to access the files and measurements inside of your device remotely. We'll start with installing Dataplicity on our Raspberry Pi. That platform allows us to access command line of our Raspberry Pi remotely, even when it's somewhere in the field. In dataplicity.com, let's provide our email, and after achieving the special code, let's paste it into our terminal of our Raspberry Pi. Let's connect to it and let's change our user to Pi user. I have my Raspberry Pi prepared with I2C sensors connected to it, and to use the sensor, obviously we need to activate I2C interface. And obviously to use the I2C interface, we need to activate it in the raspi config setting. After that, let's reboot our device. Using the I2C detect command, we can check addresses of available devices on I2C interface, and in our case, we can see that we have available 37, 5A and 76 addresses belongs to our connected devices. Next, let's write a program that will read data from 5A sensor every second. Obviously, as lazy modern programmers, we will use GPT to write code for us. We will paste into e2ctest.py file. Obviously, it was to check out that code if it have no bugs and other things that GPT just hallucinated. In that case, it looks okay. As we can see, program works and prints data read it from sensor. Next, I want that script to communicate with another script that will save our records into the database using the post request. So let's ask GPT to extend our script with post request functionality, and that's how will it look. Our post request will send measurement and timestamp in the body of post request. GPT makes errors and sometimes tends to hallucinate, as for example in that case we need to provide the port number after localhost, which GPT just forgot to write. Let's install needed libraries to our Raspberry Pi. And another thing I found later, that GPT hallucinated data parameter inside our requests.post method. In fact, that parameter named JSON. So remember to be careful when using large language models to write code for you, and always double check it. Also, I prepared a script that receives our post request with measurements data and saves it in the SQLite database. By the way, using Dataplicity, you can debug your scripts and do all the stuff that we're currently doing sitting at your home when your IoT device placed somewhere outside. Let's install needed libraries as SQL Alchemy to manage our database, and FastAPI and UVcorn to make localhost server. Let's start both of our scripts in two different windows, and we can see that they are successfully communicating. Server script receiving data and client script successfully sending it.
In that video you learned how we can debug our program executable scripts remotely, and in the next video I will show you how we can access our data files in our IoT device remotely also. See you next time.